Hello everyone, I thought I'd record a short video showing how to get started in the Lab 3 for this week. So I'm going to go ahead and download the lab data file. And let's see. We'll open that up. Okay, and so here is Fathom, and this is what the lab file looks like when we start it up. And what we want to do is we want to simulate or recreate a sampling distribution from our population. And so what we're going to do is in our population we need to edit our case table so that 20% of the people in our population text daily. So we'll say 1 represents texting daily and 0 does not represent texting daily. And so what we will do is we come to this table that represents the population, and where it says text, there's nothing there, but we're going to just enter in 2 1s and 8 zeros. Okay, and so now I have a total of 10 entries in my case table for the population with 2 1s and 8 zeros. Okay, and so this represents the population where 20% of my values here are 1. And what I want to do is from the population I want to draw a sample. Okay, so to do this I select my population, okay, click this box, and I go to the menu where it says object, go to collection and select sample cases. Okay, and if you're following along in the video, of course you can pause this and just rewatch exactly what I'm doing. So the idea is I select the population, I go to collection, and I click sample cases. And that creates this new box over here that says sample of population. Okay, and in order to speed things up, I'm going to uncheck this box that says animation on. Okay, we want to make sure that it says with replacement, because if I have with replacement turned off, then the largest sample I can draw from my population would only be 10 because my population only has 10 entries in it. By turning on with replacement, I draw someone and I put it back, and therefore my population is technically of infinite size because I'm doing it with replacement. And we'll leave everything else. We can say we only want to select 10 cases at the time. And then what we want to do is we want to gather measures from our sample. Okay, so every time we draw a new sample, we're drawing 10 new items out of the population into our sample. But what we want to do is we want to record what proportion are 1s versus 0s. Okay, and so in order to do that, in the same thing that says which is called the inspector, I click on the tab that says measures over here. Okay, I click that, and then I want to enter in where it says formula. I want to double click that and type in count parentheses text equals 1 divided by count of text. Okay, and we're going to call this measure proportion texting. Okay, which will represent the P from my sample. So I'll call this prop text, and then where it says formula, I'm going to change this to count of text equals 1, and then I hit divide by count of text. Okay, so that's what it should look like when you do it. Count of text equals 1 divided by count of text, and that will tell me what proportion of these values that I've sampled have 1s versus how many I've sampled in total. So I click OK, and there we go. And it says, when I drew a sample, right now the sample that I have is 20% texting, which is what we expect. Okay, I can click sample more cases, and I come back to measures, and this time only 1 person was texting when I drew that sample, and so therefore my value here is only 0.1, and we can see that change from sample to sample. Okay, so now that we have our measure set up, what I want to do is I'm going to select sample of proportion, and I'm going to right click, and this menu pops up, and I'm going to click collect measures. Okay, and that brings up this green box over here. Okay, measures from sample of population. So right now here I'm just following along the instructions that says, as you have in previous labs, collect, and we can turn off the animation, and you should select the replace existing cases option as well. So I will turn off animation and turn on replace existing cases. And it says, once you've desired the number of samples, and it says do at least 100. Okay, so we'll collect 100 measures here. So I'll click 100, and there we go. And it looks like it is done. We can kind of see. We can look in here, and we can see over here that the proportion of people texting, sometimes, like this time I got, in this one I got 30% of people texting, here only 20, and then there 40, so on and so forth. This is what we have after looking at 100 of these things. Okay, and we can go and measure any of these things. I can create a graph from here. Okay, and so here is a dot plot showing the amount that that people are texting, and we can kind of get an idea. And so here it looks approximately like 33 or 32 people. 32 of my random samples have proportions of texting at 20%, and about 25% of my random samples have people texting around 10%. Okay, and then so I think one of these questions asks back here, do simulations of n equals 10, n equals 100, n equals 1,000. And it says if you take a sample of n equals 10, typically how far is a sample proportion in terms of percentage points from the assumed population proportion of 20%? What about for size n equals 100, n equals 1,000? You should do at least 200 repetitions. Okay, so let's see. Let me come back here, and I'm going to say I want to do 200 repetitions. Okay, there we go. So this is after 200 repetitions, and every time I run this, it changes a little bit, sometimes more than others. So maybe to stabilize it, I can just do 2,000, and it's going to take a little bit longer, but it's not too terrible. Okay, so after 2,000 measures, this is kind of what we get. So it looks approximately about 600 out of 2,000 have proportions of 20%, and then a large number, about 550-ish, okay, and then another 400. So here, out of our 2,000 measures, if I have to do 600 plus 400 plus 550, something around there, I've got about 1,550 out of the 2,000, just ballparking it. So that's about, a little over 75% of the measures are between 0.1 and 0.3. So that's about 75% are within 10 percentage points of the population proportion of 20%. So we could write something like that for that. And we can see how this might change if I come over here, and when I inspect the sample, instead of taking samples of size 10, we can do samples of size 100. Okay, so if I do samples of size 100, I'm going to click sample more cases here. We're still dealing with this. And then over here I have to change, take my measures. So I'll do 2,000 measures of 100. This is going to take a little while on the computer, but we can run it, and there it goes. And so what we're going to see is our histogram is going to change, where I'm no longer just getting 20% and 10% and 30%, but because I have 100 cases or 100 people in my sample, you know, I might get 21 or 22 or 24% or 16%, something like that. And so we'll let this finish running and we'll take a look at what happens. Okay, and so here it looks like something very much like the normal distribution. This looks like 18 and 19%. These values look like 21 and 20 and 21%, and here I've got values of 22 and 23%. And so, you know, kind of just ballparking this again at 2,000 repetitions, it appears that you know, I got 300, and that goes down to 16% here. Oops. So let me just kind of click this bar again. Here, maybe I'll make this a bit larger. This is 16 and 17, 18 and 19, 20, 21, 22, and 23. So it appears, you know, I got 300 plus around 450 plus another 400. So that's about, what is that? 900, about 1,200. That's around 1,200 plus another 300. So around 15, you know. So between these four bars here, this covers about 75%, maybe possibly even a little bit more. I'm just kind of ballparking this, but we can, let me just see, you know, this looks to be around 340. Just eyeballing these numbers, okay. This bar looks to be around 400, so I'll add 400 there. This one looks to be maybe around 420, maybe 415, you know, who knows. And this one looks to be around 300, okay. So yeah, just between these four bars, I'm getting something right around 1,500, a little around 70, you know, this is 73% if I divide this by 2,000, you know, 73%. So, you know, about 3/4 just right between these four bars. And so this bar goes down to 16%, and this one goes up to 24%. And so to answer kind of this question, it says, you know, how far is a sample proportion in terms of, you know, typically how far is a sample proportion? So I would say, you know, about 3/4 of the data are between, you know, 4 percentage points of the assumed population proportion of 0.2, okay? Because here, this one goes from 16, 17, 18, 19, 20, 21, 22, and 23%. So about 16% to 23%. So that's, you know, plus or minus around 4%, you know, however we want to, 4 percentage points. So we would say something like that, okay? And so here, you know, it says always or within blank percentage points of the assumed population proportion 90% of the time. Okay, so 90% of the time we only want a total of around 200 on the outside, and so that probably has to take us down to around here and here, but still if I go down 1, 2, 3 and up, you know, up through there, maybe about 6 or 7 percentage points on either side, or maybe a little bit more, that will get about 90% of the population between here and here. So is there I wonder if there's you know, kind of trying to get an idea of how much I've selected here. Okay, and so, you know, I'm hoping that that gets you started with answering the questions in the lab, and so so that's it. Okay, good luck.